So again, if that live session did not start properly, I will again welcome all of you to the live session. I think now we are definitely in the live session, right. So today is Sunday, and today our honorable Prime Minister has asked us to keep a Janata curfew as a message to get rid of this virus, corona virus, which has been spreading throughout the world, right. So we should all follow that, and we should stay indoors the whole day. And he has also asked us to give us a to show gratitude to the people who are actually helping us, the essential services people who are helping us to fight off this virus. So as again I have told you, in case you are having any problem in the live stream, make sure that you put them in the comments so that I am able to know this. Okay. So today what we will do basically is that today we will actually do some numericals on transformers. Yeah, we are having viewers. So all those viewers, please put something in the comments so that we are able to understand the live is going properly. So anyway, we will start with the live. So what we are going to do is that we will do some numericals on transformers. In transformers we have done a lot of numericals already, but these are some previous year questions which have been asked in some competitive exams. So the basic idea is I am doing my part. I am staying back in the home today. So I thought, why don't we do a live session so that it will be a benefit to all of you also. So we will start now. Okay. So let us take the first question here. The first question here is that it is a multiple choice question. The desirable properties of transformer core material are. Okay. So what is the desirable properties of the transformer core material? Just let me 1 second. I'll just take the thing from my mobile also, so that I can just maybe see the comments as well. Yeah, I'll just take it in the mobile. Okay, people are chatting. I'll just keep the mobile on the side so that I can see the chats also. Yeah, so that's great. Yes. So the first question is that the desirable properties of a transformer core material are. What are the desirable properties of the transformer core material? So the first option is low permeability, high hysteresis loss, high permeability, high hysteresis loss, high permeability, low hysteresis loss, and the last option here is yes, low permeability and high hysteresis loss, right. So you don't want high hysteresis loss, so that option is gone. So this B option and C, D option are gone. You don't want high hysteresis loss. The losses should be kept to the minimum. And then you know that the transformer core material is where the flux moves through the transformer, right. So this is the core of the transformer. You know that the flux is moving through the core of the transformer. So just like you want resistance to be low in a circuit, similarly in a transformer core you want the permeability to be high. Remember, reluctance should be low and permeability should be high. Therefore the correct answer is high permeability and low hysteresis loss. So the option answer will be C for this question. You want high permeability and low hysteresis loss. Eddy current loss also should be low. So that is why you provide laminations, etc. And for hysteresis loss, to prevent the hysteresis loss, you use superior core material. Next one, which of the following acts as the protection against high voltage surges due to lightning and switching? Okay. So that is the question. Yes, JM Jason, C is the answer to the first question. Yes, C is the answer to the first question. So what I will do is one thing, I will actually see the in between I will see the comments also, and also I will just take up the questions in the end of the live session. Okay, if you are asking any questions in between also I will see. This is actually it's been a long time since I have done a live session, right. So next one, which of the following acts as a protection against switching voltage surges due to lightning and switching? You know that during the phenomenon like lightning and switching, there might be high voltage surges in the transformer. So what is the device that is used to prevent that? So is it a breather, is it a conservator, is it the horn gaps, or is it the thermal overlaid relays? So if you want, you can put that answer in the comments also. Let me just see if somebody is putting that in the comments. Okay, if you want, you can put the answer in the comments also. Okay, I'll just see the stream quality also once again. Okay, the stream is healthy, so that's not an issue. Yes. Now the breather of the transformer, you know that why a breather is used. See, in a transformer you have a device which is called breather, which is filled with something which is called silica gel. Okay. Now, why this is important? See, when the transformer is going through its cycles of operation, the oil inside and the entire transformer, it actually expands and contracts little bit. So, there is an airflow which goes from the ambient and into the transformer, and into the transformer means there is transformer oil. And once the oil air gets inside the transformer oil, the problem is you might have the dielectric failure of the transformer material, or that is the oil of the transformer. So, you do not want that. So, what a breather does it, because there is silica gel, any moisture which is present in the air, that is trapped in the silica gel or the breather. So, the function of breather is not to be a protection against high voltage surges, it is to prevent the entry of moisture into the transformer. So, breather is not the answer. Conservator conservator is actually a tank which is filled with oil. So, in case the oil level of the transformer is going down, the oil will come from the conservator and balance the lost oil. So, that is not the answer. Thermal overload relays, you know what is that? It is for protection of the transformer from the overheating issues. So, here the answer is actually horn gaps. Okay, the answer is horn gaps. For the next question, the answer is horn gaps. So, let me see if somebody has answered it. Okay, this is the answer C. 267, the question is answer C. Next question, the efficiency of two identical transformers under load conditions can be determined by. Okay. Now, for efficiency, you know what is efficiency? Efficiency is output divided by input plus efficiency is what? Output divided by input, output divided by input, right. So, anyway, for to find the efficiency you need the losses, because you can write it like this: output divided by output plus losses. Input is output plus losses. So, you need the losses of the transformer. So, what are the losses? The losses are usually the copper loss and the core loss, copper loss and the core loss. So, to find the copper loss of this transformer, you are having short circuit test. To find the core loss, you are having the open circuit test. So, in the open circuit test, you are only finding the core loss, and in the short circuit test, you are only finding the copper loss. So, only doing those tests will not give you the efficiency. If you want to find the efficiency with one test, you have to go for the back to back test, okay, or it is also called as the Sumpner's test. So, back to back test or the Sumpner's test you have to use to find the efficiency of the transformer under proper loaded conditions. Okay. So, here the answer will be A, the answer will be A. Let me see if somebody has given the answer. Yes, 268, somebody has given the answer A. Conan the detective has given the answer A. JM Jason has answered A. Hariharan TV has also answered A. Congratulations. I cannot give you any prize money like Kaun Banega Crorepati, but you will have the satisfaction of giving the correct answer. Okay. So, that is a good thing. Good that it is becoming an engaging live video. Okay. This will be not very difficult questions, because a live session and doing a difficult question in live session is a bit time consuming. Okay. Why doing numericals is important? See, doing theory is okay, you will remember the theory, but the importance in competitive exams is to use that theory in solving questions. It can be numericals or it can be theory questions like this also. So, you have to get used in seeing these types of questions, so that you can react like that. Already you are having the knowledge, but when you see the question, you have to react with that knowledge and you have to give the correct. That is why practicing these numericals is very important. Okay. Now, next question, 269. For an ideal transformer, the winding should have. Okay. So, maximum resistance of the primary, least resistance on the secondary, least resistance on the primary, maximum resistance on the secondary, equal resistance on the primary and secondary, and the last option is no ohmic resistance on the other side. See, you do not want the losses on the primary side or the secondary side in the transformer, right, copper losses. So, the first option gone, second option gone, equal resistance. If you have resistance, you are having losses. So, the answer here will be no ohmic resistance. In ideal transformer, I already told you, permeability infinity and the copper losses or the resistance of the transformer should be 0, no ohmic resistance. So, in this case, the answer will be D. Let us see if somebody has given the answer. Yes, D. I would recommend that you put the question number also and tell the answer, okay. So that will be better. Now the next question, two single phase 100 kVA transformer each having different leakage impedance, okay, different leakage impedance are connected in parallel. When a load of 150 kVA 0.8 power factor is applied, okay. So see, this is a theoretical type of question, they have not given a lot of information here, because you know that in parallel operation of transformer, you know that the loading on a transformer is given, for example SA, that will be the load multiplied by the impedance of the other transformer divided by the total impedance. This is the formula, and for the other one is SB will be equal to SL into ZA divided by ZA plus ZB. That is the current dividing rule, right. So here you do not have the value of ZA and ZB, but they have told that the impedances are different, okay. So in this case what will happen, because the impedances are different, the loading also will be different on the different transformers. See, just because they are both 100 kVA, it does not mean that they will load exactly the same. So 150 kVA will not divide as 75 and 75, because their impedances are different here. So what happens if you have done numericals in this type of questions, both the transformers will be working in different area, and in fact one will be working, for example the load is 0.8 power factor lagging, right. So the correct answer here will be, one of the transformer will be operate at a power factor more than 0.8 and another will be operating at a power factor of less than 0.8. So one transformer will be in this region and the other transformer will be in this region. If you have done numericals, you might have already seen that if you calculate for this particular condition, you will find that one will be more than 0.9 operating at power factor more than 0.9 and one will be operating at less power factor, okay, less than 0.8. In this case it is 0.8, so it is like that. So that is the answer for 270. 270, yes, 270C. Conan detective is very smart. Samir and Mondal also has given the answer, the correct answer, okay. So great, Conan detective has been answering a lot of questions correctly, great. Next one, 271, the Scott connections are used for. So when I was discussing the single phase induction motor, I already told you, to get a balanced two phase supply from a three phase supply, there is a special connection in transformer which is called Scott connection. While taking transformers, I have not discussed this, because I wanted that you to do on your own, okay. So if you had done that, you will be able to answer this question. So Scott connections are used to convert three phased balanced supply into two phase balanced supply, okay. So in this case, what is the option? 3 phase to 2 phase, right. So the answer is C, okay. Let us see if somebody has given the answer correctly. 271C, both of you are doing, Conan and Samir and Mondal are head to head competition, that they are answering all the questions correctly. That is great, it is a very good way to revise all these things. Yes. Next question, 272. So this is a numerical. Two single phase transformers with equal turns, remember it is equal turns, have an impedance of 0.5 plus j 0.3. This is actually J1, okay, J1, okay, there is a small typing error I think here. So 0.6 plus J1 here, ohms with respect to the secondary, okay, with respect, so these both are given with respect to secondary. So this is the total impedance of the transformer referred to the secondary, this is the total impedance of the transformer referred to the secondary. If they operate in parallel, how will they share a load of 100 kilowatt at point power factor lagging, okay. So this question is very simple. So this is your transformer A and this is your transformer B, okay. So A transformer is 0.5 plus j 0.3, B transformer is 0.6 plus j1, right, and they are together connected to a load of 100 kilowatt at 0.8 power factor lag, 100 kilowatt at 0.8 power factor lag, okay. So now we have to find what is the sharing that they are going to do here, okay. So this is also a very simple question, there is nothing to be worried about this question. See, first you have to convert this, you know that the formula is SA is equal to SL into ZB divided by ZA plus ZB, right. So here you have to find first what is SL value. See, SL is not given directly, SL is in kVA, this is given in kilowatt. So here SL will be equal to kilowatt divided by 0.8, right. So, this will be equal to 100 divided by 0.8, which is 125 kVA, which is equal to 125 kVA, right. So, and what is given? It is given that it is 0.8 power factor lagging, right. So, it is given 0.8 power factor lagging. So, you have to write everything in terms of polar form here, okay. So, 0.8 power factor lagging, if you write in polar form, so this let us find for the SA here. So, SA will be equal to 125 angle minus 36.86 power factor is lagging into ZB. ZB is this value. So, convert this into polar form. So, 0.6 plus J1, I will not convert, divided by total impedance. So, 0.6 plus J0.3 plus 0.6 plus J1, okay. So, if you find this, you will be able to find the load sharing of this particular transformer here, okay. And to find in kilowatts, you know the power factor angle, you can directly find it in kilowatts also. Yeah. So, this is SA, right. So, you will get SA in terms of some value kVA and a power factor angle. So, you combine those two and you will same formula you can use, you will get the SA value with some power factor angle. So, if you use this formula here, so that value multiplied by the power factor will give you in kilowatts. SB will be equal to SL into ZA divided by ZA plus ZB. This is 125 angle minus 36.86, and the other transformer is 0.5 plus J0.3 divided by this total. So, 0.5 plus J0.3 plus 0.6 plus J1. Okay, here also you can find. I am not doing the entire solutions because that is something that you have to do. Okay. So, Konan and Samiran Mondal, Shweta and all of you, Hariharan, all of you try this numerical, and I am sure that you will be able to get the correct answer. Yeah. Let us move on to the next question here, lot of questions are there. The losses on a transformer are, okay. First one, copper loss, eddy current loss, hysteresis loss. So, they have told that there are three losses in a transformer: copper loss, eddy current loss and hysteresis loss. The constant power loss of a transformer is given by, you know that the constant loss of the transformer is the core loss. Core loss is nothing but hysteresis loss plus eddy current loss, right. Hysteresis loss plus eddy current loss. So, eddy current loss is 2, hysteresis loss is 3. So, the answer will be 2 and 3 only. So, in these questions sometimes it is 1, 2, 3, this might be a little bit of confusing. So, you have to be very careful while attempting all these types of questions. So, that is why doing these questions is very important. So, here the answer will be C. Let us see if somebody has given the answer correctly. Yeah. In the mobile it is, yeah, okay, okay, yeah. Now, next question, 274. Which of the following will improve the mutual coupling between the primary and secondary circuits, right. So, coupling is how much of flux is moving from the primary side to the secondary side. The coupling is the measure of how much effectively the flux is moving from the primary side to the secondary side. So, what will improve? Which of the following will improve? So, you know that to improve the flux flow, you have to have low reluctance magnetic core. That is the only way. So, transformer oil high breakdown voltage, this is for actually dielectric conditions. So, that the transformer does not have dielectric breakdown. So, you can have transformer oil high that is not related to coupling. High reluctance magnetic core, no, you have to have low reluctance magnetic core. Winding material of high resistivity, no, that is not related to this, but you should have the resistance of the winding material should be less actually. Anyway, so the answer here is low reluctance magnetic core, low reluctance magnetic core. The answer is D. So, this thing came here, so I will just write down that here, that break the chain thing will be here. So, W core is equal to WH plus WE. Okay, so that is our 275. The secondary of a current transformer under operating conditions is short circuited to avoid it. See, in current transformers, you know that the current transformer secondary is always shorted, or it is given through a burden, it is given through a load, where PT secondary is always open. These are two important conditions. So, why it is to be shorted? Why it is to be shorted is because if you open the circuit, the transformer, the secondary of the transformer will induce CT will induce a huge voltage, and because of that a huge magnetizing current will flow, which will cause the core to go into saturation, and high voltage induction. So that is the answer. High voltage will induce and the core will go into deep saturation or very high saturation local. So 275 answer will be C. Okay, 275 answer is C. So let us see if somebody has got that question. 275. 275 C. Yes, great. More people have joined. I will just welcome all of them. Anusha has joined, Manoj has joined, Abhi has joined, and Shweta has got the wrong answer. Break in the primary winding. See, in the CT, the primary winding is the line which you measure actually. Okay, it is the line which you actually measure. Okay, so that is the thing. So that option is not correct. Okay, yes. In case there is any discrepancy in the answers, we will just I will try to, in case you are thinking that some answer which I have told, see in these questions, in these numericals, you have to select the best answer. Okay, best answer under the normal operating condition. See, it is under operating conditions they have given, right? So this word is important here, under operating condition. That means the system input is okay. Your CT is the device. CT is the device. So you have to only think about that. You are having access to that device only. Okay, maybe that is why in most of the books they have given the answer to be C. In case there is any discrepancy, we will see. Okay, okay, yeah, okay. So that is the thing. The under operating condition, that might be the word. That is why some of you might have got the doubt why there is break in the primary winding. Okay, so that question is over. Okay, next one. The inductive reactance of a transformer depends on. The inductive reactance of the transformer depend on. So you know that in a transformer you are having leakage reactance, right? So I already told you the reactance component in the equivalent circuit is modeled from the leakage flux of the transformer, right? See, in a transformer you see you are having the resistance of the primary and you are having leakage reactance, right, X, and then you are having your core loss and you are having your magnetizing component X phi. This was the equivalent circuit of the transformer, right? So I will just put it as referring to one side. So we will refer it to the primary side. Okay. So this component is actually due to the magnetizing component. Okay, but this component, okay, the inductive reactance of the transformer, this is modeled after the leakage flux. If you have not watched that video, you can go and watch that, where I have in depth have given the how equivalent circuit parameters have derived. So here 276, the answer will be leakage flux. Okay, let us see if somebody has got the answer correct. Yes, 276D, yes, Anusha, all are getting the answers correct because all the questions are very simple, right? That is why all of you are getting the answer correct. So so let us move on to the next question. 277, which of the following connection of the transformer will give the highest secondary voltage? See, in these questions you should be so prepared that you just see the options and you will get the answer. Okay, but in this case we will, that much of preparation you should be having because these are all general results. Okay, but for the time being we will do in depth, everything we will do in depth here. So delta primary, delta secondary. What is the question? Which of the connections will give highest secondary voltage? So if you are applying voltage of VL in the input, which will give the highest voltage in the secondary side? So the first is delta, right? So you are applying VL voltage. So I have told you the procedure how to calculate this already. So first you convert into phase voltage. So the phase voltage, delta connection, line and phase are same. So it will be VL. Then you are having the coefficient of coupling K. So here from primary side to secondary phase, this will become K into VL, right? V2 by V1 is equal to K. And from here you convert again this phase value. So this is line, this is phase of the primary side, and this is the phase, and this is the line of the secondary side, right? So delta both are same, so you get KVL. So in delta connection you give VL, you get KVL outside. Okay, let me see if somebody has already gotten the correct answer. 277 B. Okay, somebody are getting the answers correct. So delta, next is delta star. Some people are already having the answer in your fingertips. That's great. So you are having VL, phase voltage VL, then from primary to secondary phase it will become K into VL. Now in star connection, when the line voltage is √3 times the phase voltage, so this is the line side of the star side. So, this will be root 3 into KVL, right. And next third is star primary, star secondary. So, you have applied VL, phase voltage will be VL divided by root 3, then towards the secondary side it will become K into VL divided by root 3. Here again the line voltage you have to multiply by root 3. So, this will become KVL. So, these two values are exactly the same. And finally, is the star primary delta secondary, star delta. So, VL you apply, I am not having any more space. So, this is VL divided by root 3, and in the phase side of the delta side it will become K into VL divided by root 3, and this will become K into VL divided by root 3. So, out of all these answers you can clearly see it is the delta star which has the maximum connection. So, the answer here will be B, answer will be B, okay, delta primary star secondary. Okay. Which is the lowest? Can you tell me which one will be the lowest value? Out of all these connections, which will be the lowest? Now, we have seen the highest, right? I will wait for some time, which will be the lowest. The problem is that sometimes these chats take a little bit of time. 277A. Anusha, you have told the answer for this question or the question which I have asked. I think the lowest will be the star primary delta secondary, right, because it is KVL divided by root 3, right, star primary delta secondary. Yes, Conan, I think the answer is answer would be D if the question was the lowest, right. If the question was lowest, I think D will be the answer, right. You can try it on your own also. When you are doing live sessions, you are under so much of pressure and tension because I am talking live to you. So, in case I make some mistakes, make sure that you rectify them for me. Okay. In a transformer, next question, in a transformer, if the iron losses and copper losses are 40.5 kilowatts and 50 kilowatt respectively, then at what fraction of load will be the efficiency be maximum? Simple question, you know that the efficiency will be maximum when the copper losses, total copper loss equal to the iron loss, right. And you know that in our lectures we have 1 minute, let me just see if something is getting blocked here. No, nothing is getting blocked. Okay. We have seen that we use the term WCU to show full load copper loss, right. And for some fraction of the full load copper loss, for x fraction of the full load copper loss, we told that value was x square WCU, right. And we saw that when x square WCU is equal to the iron losses, you are having maximum efficiency, right. X square WC is equal to W, you are having maximum efficiency. So, the fraction at which maximum efficiency occurs, is equal to root of Wi divided by WCU, right. So, this is root of Wi is how much? 40.5, right, 40.5 divided by 50. I think here the answer you will be getting 0.9, I suppose. Do you get the answer as 0.9? I forgot to calculate this. So, answer is 0.9, 278 answer is 0.9, right. Samiran and Conan have, Prabhavati Harshan has also told D. So, I think the answer will D. Everybody are telling D, so answer will be D, right. Conan has gone a step ahead and answered the 279th question also. Great. I am feeling very happy that you are all interacting with me so much. Yeah. So, next is 279. Can a 50 hertz transformer be used as a 25 hertz if the input voltage is maintained at constant voltage and the rated value corresponding to 50 hertz? Okay. So, they have told first option is yes, since the voltage is constant, current levels will not change. No, flux will be doubled, which will drive the transformer core into excessive saturation. That itself is a bad point. So, mostly that will be the answer, right. Let us see what will be the answer. No, owing to the decreased reactance of the transformer, input current will be doubled at the load. Yes, at constant voltage insulation will not be overstressed. Okay. See, one point here it is correct. Yes, at constant voltage insulation voltage will not be overstressed. Okay. But we have to see what is the answer that we require. Okay. You know that flux is proportional to V1 divided by F. Flux is proportional to V1 divided by F. So, I already told you, you can make the transformer work in different frequencies, but the flux has to be constant. In this case, V1 is constant, only F is varied. That means V1 by F ratio is not constant. V1 by F ratio is not constant. That means flux is proportional to 1 by F. Because V1 is constant and only frequency is varied, flux is inversely proportional to frequency. And what are you doing? Excuse me, I will just drink some little bit of water. Yes. Yeah, when the frequency is decreasing, the flux will increase. When flux increases, magnetizing current drawn will increase, and what will happen because of this flux increase, and because the flux is decreasing 2 times, right? Flux is decreasing 2 times, the flux will the frequency is decreasing 2 times, the flux will increase by 2 times. So, the flux will be doubled, due to which the core will go into excessive saturation. So, the answer is B. So, the answer is B. The exact answer is B here. Okay. Excuse me. Okay. Let us see what is the next question. Let us see if somebody answered that question first. V by F is not constant here, because the voltage is constant, only the frequency is changed here, right. So, that is the thing. Let us see the answers here. I have already told you, just put the question numbers also, because simply if you put a number I will not be able to see. I forgot the question number. 279, right. 279. Oh no, 279 the answer was B. 279 the answer was B. 279 the answer is B. Some of you have got it wrong. Let me see why. 279 answer is B. Yeah, 279 everybody has given the answer B. Okay, so that is great. 279 has everybody has given the answer B. Great. Okay. Next question, 280. Short circuit test is performed on a transformer with a certain impressed voltage and rated frequency. If the short circuit test is now performed with the same magnitude of impressed voltage, but a frequency higher than the rated frequency, then okay. So, what they are telling, let us first draw the short circuit test. So, this is RE. On the high voltage side we will take, this is XCH, and it is short circuit test, right. So, the short circuit test, the voltage is called VSC, and this current is called sorry for that, and this current you short circuit voltage you apply, the rated current will flow. So, what they have told here is that the voltage is not changed, but the frequency is higher. So, out of these 2 parameters, which is the parameter which is dependent on frequency, we have to see. So, RE is not dependent on frequency, but XC is dependent on frequency, right. XC is equal to 2 pi f into L, right. So, what they are telling is that frequency is higher than the rated frequency. So, frequency increases, XCH increases. So, let us see what is the options. So, magnitude of the current and power factor will increase, magnitude of the current will decrease, but power factor will increase, magnitude of the current will increase, but power factor will decrease, magnitude of the current as well as the power factor will decrease. So, when XC increases, you know that ZDH also increases, and once the total impedance increases, the current value will decrease. The current value will decrease here, the current value is decrease. So, you take the options of decrease of current. So, decrease of current is B option, and decrease of current is B option. B and D are decrease in current option. Now, next we have to see power factor. So, you know that power factor cos theta SC, power factor will be how much? Adjacent side by this one, right? So, R by Z. So, when Z increases, R is constant, Z increases, cos theta will decrease. So, both are decreasing, ISC is decreasing, cos theta is decreasing. So, both magnitude of the current as well as the power factor will decrease in this. So, 280, the answer will be D. Let us see if somebody has got the answer correct. Yes, many of you have got the answer correct. Okay. Next question, while performing the open circuit and short circuit test on a transformer, to determine its parameter, the status of the low voltage and high voltage winding will be such that. Okay, I already told you in open circuit test and short circuit test. So, usually the open circuit test you do it in the which side? The open circuit you do it in the LV side, because you have to only apply less voltage. Also, the current drawn during open circuit test is very less. So, because LV volt side has less resistance, you will be able to measure it properly, very less current, so you will be able to measure it properly. High voltage side you keep it open, right. So in OC test HV is open, and in short circuit test LV is shorted. Okay. So you have to see these sentences, when you see sometimes you will get confused. So you have to make sure that you practice all these questions. So let us see, open circuit LV is open, wrong, open circuit HV is open, short circuit LV is short. So the answer is B, right, the answer is B. So the answer is B. I think most of you might have got this correct. Okay. Somebody has given 281, which is a 281 question. Somebody has given the wrong answer there, I think. Conan has given the correct answer, but Samir and Mandal has given 2 answers. Acha, okay, now you have corrected yourself. Okay, okay, great, great, great. Yes, yes. Now, all these questions are from previous IES, right? So these are all good questions, so don't worry about that. So next is question. 2 kVA transformer has iron loss of 150 watts, full load copper loss of 250 watts. Maximum efficiency of the transformer would occur when the total losses. Okay. So you have to find the total loss. So total loss is the total copper loss plus total iron loss. Now this question is a tricky question, because what will happen, some people what you will do, you will take x square WCU is equal to Wi, WCU they have given full load copper loss, Wix is equal to root of Wi divided by WCU, all these things will you do, then you will again calculate x square WCU, then you will take x square WCU plus Wi, that is the total value here. But this is a very very simple question. See, iron loss they have given at 150 watts, right. At maximum efficiency iron loss will be equal to copper loss. That means at maximum efficiency Wi which is equal to 150 watts will be nothing but the total copper loss, right. So the total losses will be equal to Wi plus total copper loss. So that is 150 plus 150 or 2 into Wi, that is 300 watts. So it's a very fast question, you have to do it very fast. So the answer is C. The answer is C. So you will see 300 iron loss constant, yes, great. Okay, great. We are doing a lot of questions now. 16 pages are there, so we have come halfway. 8 pages are over, a little more questions we will do. Okay, so next question, let us see what is the next question. If the frequency of the input voltage of a transformer is increased, keeping the magnitude of the voltage unchanged. Okay. So what they are telling, frequency of the input voltage of a transformer is increased, keeping the magnitude voltage unchanged. That means in V by F is not constant, that is only frequency is changed, voltage is not changed. They are asking about hysteresis and eddy current. So here that case 1, case 2 concepts will come. Okay. So you know that in case 2 where V by F is not constant, you know that WH will be proportional to V1 raised to 1.6 into F power minus 0.6, and WE is proportional to V1 square. So this is the case 2, when V1 by F is not constant, right. And in this case voltage is not changed, so you can write WH to be you will write 1 by F raised to 0.6. Okay. So this is the condition here. So what they are asking, both hysteresis loss and eddy current loss will increase. Hysteresis loss will increase, eddy current loss will decrease. You can see clearly here the eddy current loss will be constant, that is the important, because voltage is not changing, voltage is constant. So WE is equal to constant, because in the numerical V1 is equal to constant. V1 was changing in the numerical, is a different case, but here in numerical V1 is constant. Hysteresis loss will decrease, eddy current loss will increase. Hysteresis loss will decrease, but eddy current loss will not remain unchanged. So you don't have to see any other option, only see this option. Eddy current loss will remain unchanged. So the answer will be D. You don't have to even bother about the hysteresis loss. Anyway, see, frequency is increasing naturally in this case, because it's 1 by F, frequency is increasing, WH will decrease here. Let us see if somebody has given the answer correctly. 283. 283, let us see if somebody has given 283. There is no 284 question. Okay, yes. So Some of you are very active and doing all the questions properly. I hope you are finding this entertaining. Otherwise you will be bored and the Janata curfew will get over today. Stay in your house. That is one reason, another reason why I am doing this video, so that you all have to stay in your house, because this Janata curfew is a very important thing for the government now. We have to see whether such implementations are possible, and also maybe they want to see what is the impact in the economy, etc. So today please you stay inside your house unless there is some emergency condition like medical or something like that. Okay, so today please stay in the house and break the chain. I hope all of you are practicing proper hand hygiene and social distancing. Okay, so please make sure all these things. Now next question: for successive parallel operation of the two single phase transformers, their most essential conditions are: percentage impedances are equal, percentage impedances are not equal, per unit impedances are equal, right? Polarities are properly connected, turns ratio are exactly equal, KVA ratings are equal. So in this case the answer will be clearly polarities have to be properly connected, right? So one is the voltage ratings, nameplate voltage rating should be same, that is one condition. Polarity should be same, and in case of three phase transformer the phase sequence also should be exactly the same. So here polarity should be properly connected. 285, let me see, somebody might have answered 285. Shweta, this answer 285 is not A, it is B, because percentage impedance, let me just get back to that. Okay, I am having a small doubt in this, because transformer I took it long back. So but actually most essential condition, yes, most essential, this is the trick here, it is the most essential condition. Which is the most essential condition? So sometimes there might be multiple correct answers also to a question, but I think in transformers it is the per unit impedance and percentage impedances are the same. So yes, I think the answer A also was correct, but it is not the most essential condition. The most essential condition is the polarity to be exactly the same. Okay, so I hope Shweta, I think you might have got that answer. Okay, in case there are discrepancies, I told you we will discuss it in a later point of time, but I think here the important thing is the word most essential condition. Okay, so in multiple choice questions you have to select the most correct answer. There might be sometimes two answers which are looking the same, but you should select the most important question. 286, in all cases of electromagnetic induction, an induced voltage will cause a current to flow in a closed circuit in such a direction that the magnetic field which is caused by the current will oppose the change that produces the current. Which is this law? This is not Faraday's laws of induction, not Faraday's law of magnetic induction. This specifically is the Lenz's law. This is not the Ampere's law, it is specifically the Lenz's law. Okay, so that is also over. Let us see if anybody made a mistake there. 286. Yes, Shweta, I think you have got the point, right? Yes, great. 285, answer B. Anusha, Shweta, Hariharan, Conan the detective, Samir and Mondal, they are very active. This is great. Okay, very happy that you people are following the videos properly. Okay. Next question: if the rated voltage from the power lines is applied to the primary of a single phase transformer which is operated on load, both input and the currents are sinusoidal. Input voltage currents are non-sinusoidal. Input voltage is non-sinusoidal and input current is sinusoidal. Input voltage is sinusoidal, input current is non-sinusoidal. Okay, so this is a trick question here. Actually it is a magnetizing current which has that non-sinusoidal nature, right? So remember, it is a magnetizing current. However, the input current coming will be always sinusoidal. Input current will be always sinusoidal. So here the answer will be, what was the question? This is the question number after Lenz law, right? So yes, so here the answer will be both the input voltage and the current are sinusoidal, because the source cannot supply a third harmonic component. The third harmonic component is within the transformer, right? It is within the transformer. So here the answer will be both the input voltage and the current is sinusoidal. Let us see. 280, here the question number is not there. Oh, I am sorry. 286, I will just put 287, 288. Okay. So that is the answer there. Next question: two three-phase transformers are to be connected for parallel operation. Which one of the following arrangements is impossible. It is impossible, they have asked. Star star delta delta, star star delta delta, they are coming in the same phasor group, right. So, for paralleling they have to be in the same phasor group, same phasor group, that is 0 180 or 180 plus or minus 30 or plus or minus 30. Okay. So, this is the condition. So, star star delta delta same group, star delta delta star delta delta, let us keep that option, star delta delta star same phasor group, and delta 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 delta. So, the answer is delta star and delta delta. Delta star and star delta is coming in the next phasor group, and here you are having star star and delta delta, right. So, B option is correct, because that is impossible to connect, you should not connect. It is possible, but the transformer will just burn off, that is the only thing, you do not want that. So, you should not connect it like that. Okay. Now, the next question, 290, this question let me take it for another time, okay, because I have not prepared the answer. That is already, sometimes I might also, I do not want to be give a random answer for this. Okay. So, we will just move on to the next question. Yes, 291. A 50 hertz operation, a single phase transformer has hysteresis loss of 200 watts and eddy current loss of 100 watts. Its core loss at 60 hertz operation will be. Here, now one assumption here you have to take is that the BM value is constant. They have not given in the question, but when I calculate it respect to BM is equal to constant, that time only you are getting the answer. So, when BM is equal to constant or V by F is equal to constant, it is coming under case 1. It is coming under case 1. So, in case 1 you know that WH is equal to A into F, and the eddy current loss will be hysteresis loss A into F, eddy current loss is B into F square, right. So, let us find the first value. This is the way to do these numericals. So, hysteresis loss 200 is equal to A into first operation condition is 50. So, A is equal to 4, and eddy current loss is 100 is equal to first operation condition is 50. So, B into 50 square. So, B is 0.04 here. You have to find the core loss at 60 hertz operation. So, core loss will be equal to hysteresis loss plus eddy current loss. Now, because it is case 1, so this will be equal to A into F plus B into F square. In this case, frequency is increased to 60 hertz now. So, this will be equal to 4 into 60 plus B is how much? 0.04 into 60 square. Okay. So, you will get 384 watts. I calculated this value. So, the answer is 384 watts. So, let us see how many questions. Oh, question is very small to read. Yes, that delta delta star star, right. So, it is okay that you know that transformer in the same phasor group has to be connected in the same value. Okay. So, that is the only thing. Some of you are calculating this numerical so fast. I do not know how, I myself cannot do all these things, but I am not preparing for some exams, right. Good thing that you are able to calculate all these things very fast. Now, next question. To prevent the maloperation of the differentially connected relay while energizing a transformer, the relay restraining coil is biased with, I have already told you, the inrush current of the transformer is filled with second harmonic currents, right. The inrush current in the transformer is filled with second harmonic field. So, just because that current is large because of the second harmonic, every time a relay is tripping, you will never be able to turn on the transformer only, right. So, you have to have the relay and it is biased with the second harmonic current, okay, second harmonic. So, second harmonic current it will analyze, okay, I will not trip, second harmonic I will analyze, I will not trip, that is it, okay. So, the answer is second harmonic current, not third, fifth, seventh. The inrush current is filled with second harmonic current. Let us see 293, 293A. Yes. Okay, so you are getting the answers correct. Few more questions only. A single phase transformer fed from the rated voltage operates at no load. The core loss of the transformer is assumed to enable the current drawn by the supply will have the waveform. Okay, current drawn from the supply. So, always important thing is that current drawn from the supply. Supply cannot give you third harmonic current. Supply cannot give you third harmonic currents. The transformer can only supply you sinusoid. The power supply can only supply you sinusoidal voltage, because it is a balanced power supply. Everything which happens is inside the transformer, right? It is going inside the transformer. So whenever somebody is asked current drawn from the supply, it will be always the sinusoidal value. Here the answer is D. Okay. Yes, now the next question we will take 298. Let us see if somebody has something to say about that question. Hariharan, I think that their answer is correct, right? Thank you. Right. Next is 298. A transformer possesses a percentage. Let us see how much time this has been going on. I am not able to see how much time this has. 50 minutes. My God, this video has been going for 50 minutes. I think some of you did some of you sleep? No, everybody are going strong, right? So Samiran, Hariharan, Shweta, Anusha, all of you have been going strong. I am happy that none of you slept off in this live session. 50 minutes are over, we are going more strong. I thought that this will get over in half an hour itself, but it is going strong. Yes. 298. Transformer possesses a percentage resistance and percentage reactance of 1% and 4% respectively. Its voltage regulation at 0.8 power factor lagging and leading. Percentage regulation of the transformer is equal to percentage resistance cos theta plus or minus percentage reactance sin theta, right? Plus is for lag, minus is for lead, right? Plus is for lag, minus is for lead. So all the questions are directly given. So 1 into let us take lead condition 0.8 plus 4 into percentage reactance. So don't put 0.04 because you want it in percentage resistance. So you want it in multiplied by 100 itself. So 4 into what is the value? 4 into 4. No, 4 into 0.8. Okay. So this I think you will get 3.2%. And for the leading condition, this will be this for lag. For lead, it will be 1 into 0.8 minus 4 into 0.8. 1 into 0.8 minus 4 into 0.8. How much is the answer? I have not calculated this. Can you tell me how much is the answer? Conan has told 290, 298. What is the answer? 298. Answer is B. Okay. I am believing you, Conan. Answer might be B. Yeah, because same power factors, if you see the curve, they don't pass. You see the regulation curve, right? So in that regulation curve, you to see that in the same power factor for leading and lagging, they are a bit different. Okay. So you can eliminate this option directly actually, right? So answer I think it is B. Anybody else who has got the answer to be B? Yes. Okay. Yeah. Okay. Next is 298. Oh, badly scanned copy. See, this brown thing is because this material is very old. It is from 2000. The question papers which I collected were from 2012. 2012. Yeah, it was on 2012 when I was preparing for all these exams. So they are in a bit of a bad state, and when I scanned, it became a color copy of scan. So that is why that brown thing is coming. Okay, so don't worry. That brown thing is the symbol of a lot of hard work. Okay, remember that brown thing is a symbol of a lot of hard work. Okay. Yes, 298 question. If the applied voltage of a certain transformer is increased by 50% and the frequency is reduced by 50%, then the magnetic circuit remains unsaturated. Okay, the maximum core or flux density will be. What they are telling is that the flux is proportional to V1 by F, right? So the voltage is increased by 50%, right? Increased by, so if the voltage was 100, now it has become 150. So the voltage has changed to 1.5 V1 and the frequency is reduced to 50%, reduced to 50%. So this value will be equal to if it was 100, now it has become 0.5. Okay, so this will be 0.5 F. Okay, so now if you see this will be flux was V1 by F, now it is 3 into V by F, right? So if this is phi 1, so the new flux phi 2 will be equal to 3 into phi 1. So what is happening? change to 3 times the original value, right? It changes to 3 times the original value. See, if frequency was also increased by 50%, what will happen? The flux will not change, but here you see it will increase to 3 times the, so its answer is A, right? So people tell me if the answer is A. Shweta has told answer is A. Conan Detective is asking Chapman. See, the numericals which I do in the lectures are usually from Chapman, because Chapman numericals are very big. These are all actually previous IES questions. Okay. Yes, we are coming to the end. 302. Okay. In a transformer fed from a fundamental frequency voltage source, the source of harmonics is it the overload, is it the poor insulation, is it the iron loss, or is it the saturation of the core? Let us see. 302. Let us see if somebody is going to give answer. Shweta, for which question you have answered this? Have you answered it for 299, right? You have answered it for 299. Let us see. Waiting for Conan the Detective, Hariharan, Jim, Samiran, Shweta, waiting for your answers. 302, one answer has come. Okay. Conan has told 302D. Okay. See, the answer will be naturally the source of the harmonics is always the saturation of the core, right? It is saturation of the core is the source of the harmonics. Detailed videos on harmonics are already there in the channel. So, this answer will be D. Next, 303. A 40 kVA transformer has a core loss of 400 volts and full load copper loss of 800 volts. The portion of the full load at which the maximum efficiency is. So, here simple question, x square WCU is equal to Wi, x is equal to root of Wi divided by WCU. So, this will be root of 400 divided by 800. This is root of 1 by root 2, right? So, 1 by root 2, I think it is 70.7%, right? 1 by root 2 is usually 70.7%. So, what is the answer? 303. 303C. Hariharan, you might have gone to the, you have to click again live. Okay. Some people have also joined. Shipu Sharma has joined. Hello, good morning. Good morning, good morning. Next question. 304. So, this is the last question. Okay. Let me see if somebody could more question I have done. No, this is not required. Yeah. 304. A single phase transformer has a rating of 15 kVA 600 by 120 volt. It is reconnected as an auto transformer to supply 720 volts from a 600 volt primary source. Okay. So, you are having a transformer like this, right. It is 600 volt divided by 120 volt to 120 volt, and it is having a rating of 15 kVA, where rating is for the primary winding and the secondary winding. Remember, it is reconnected as an auto transformer to supply 720 volt. That means it is connected as additive polarity. So, dot polarities I will keep from a 600 volt primary source. So, this side is used as the primary there. So, it is connected as additive polarity, right. So, reconnection I have done. Okay. So, this is your 600 volt winding and this is your 120 volt winding, and you are providing input from the 600 volt source and you are taking the output from this side. So, here the total rating now becomes 720 volt. They are asking what is the capacity maximum load that this auto transformer can supply. This is 600 volt. So, the maximum capacity in kVA will be equal to voltage multiplied by current. So, you have to find the current which is coming through the load. So, the current, you know that it is passing through the 120 volt winding, right. So, you have to take the current rating for the 120 volt winding. So, how will you get? You will get that from this here. So, 15 kVA 15 into 10 cube will be equal to this 120 into the current rating of the 120 volt winding. So, that I 120 will be equal to 15 into 10 cube divided by 120. So, that is 125 ampere. So, the current rating of the 120 volt side is 125 amperes. So, only that much current can flow through this thing here. So, this is 125. So, the current through the maximum current through the load can be 125. Maximum current which the transformer can supply is 125 amperes. If you load it beyond that condition, it will get damaged. So, here this will be 720 into 125. So, I think it is 90 kVA, 90 kVA. Oh. Nazir Hasnif has asked so many times power electronic lectures. You can ask it once, you can ask just once, I can see it once also, because see a lot of people are watching this video also, right. So, that is why. Otherwise, I am also not able to see the comments which others have posted. I am deciding on what topic to cover in the next video after machines. So, yes, the answer is 90 kVA, 90 kVA. Okay. So, the answer is 90 kVA, right. Others, okay, okay. So, let us see, more comments are coming, more comments. Let us see how much time now. I am not able to understand where is the time. Last time I found out it from somewhere. Yeah, it is 1 hour almost. It is here. Live is 1 hour. Okay. So, I think we can stop today. My throat is also a little bit. I also have to rest a little bit of my. Let's drink some water. There are a lot more numericals which we can cover, but then for today's live session I think this much is enough. The idea is that you have to understand the numericals properly. You have to get into a habit of understanding the numericals properly, so that you will be able to use that knowledge while solving this numerical. That is why getting used to seeing these numericals is important. You studied all the theory, suddenly in the exam hall you are seeing the questions and all these confused options, all the confused options you are, this is that, voltage is increasing, current decreasing, frequency is multiplied, that, this, that, confusion. If you are seeing it for the first time, you have to practice questions so that your mind is used to all these things. So, that is important in this question. Now, let us take some questions. If you want to ask some questions, you can please ask the questions in the comment box. I have put the comment box here. So, power electronics, a lot of people have been asking for power electronics, right. I am definitely going to consider that, power electronics and control systems, because these two subjects are comparatively smaller as compared to a subject like machine. Maybe I can take them parallelly also, it is not a problem here. Shivam Saxena has asked, Samiran Mondal, you can get from engineering funda. Okay, it might be some other YouTube channel, right. So, the power electronics you are telling engineering funda. Okay, okay. I don't know about this channel. So, if you are getting knowledge from that, that is best. Knowledge from anywhere it is good. I don't have to tell that you have to only watch my videos, wait for my video. Anywhere you get the knowledge, it is good. See, even personally myself, I also go through a lot of NPTEL lectures. I follow a lot of books like Chapman, etc. I follow Theodore Wilde, then sometimes P.S. Bimbra, and which was the other book, sometimes H. Cotton and Vincent del Toro. I follow all these books, but sometimes when you don't get some concepts, I myself follow a lot of NPTEL videos also. In fact, the single phase induction motor concepts I have taken a lot from an NPTEL video, excellent video. Okay. So, please make those lectures which are not available on YouTube. See, the idea of this channel is not to make somebody like in 2021 I will cover all the videos and everybody will become expert. That is not it. The idea of this channel is to create a repository of good quality videos. Okay. So, that is going to take some time, because I have to refer a lot of books, and unless I am convinced that this content which is I am putting out is of really good quality, because good quality in the sense I myself should have no doubts when I am explaining it. Okay, so that takes a little bit of time, multiple books. See, in a concept like Transformers, I think I have followed around 3 or 4 books, including some numericals I have taken from Gate, some Chapman, from IES, etc. So these courses take a little bit of time. Okay, and other than that, you know that I am having a full-time job also. So whatever time I am getting after that only I can put in this. So the idea is to build the pillars of electrical engineering in this channel. Okay, so yes, electrical. Anusha Nath is asking good reference book for electrical machines from basic. See, for some books are good in some topics, that is why we make these videos, right, so that you can get everything in one area. See, Chapman is really good, electrical machinery fundamentals by Chapman. Other than that, one full book is you can take that book by Theodore Wilde, Electrical Machines, Drives and Power System by Theodore Wilde. And for some concept, P.S. Bimra is also okay. And so these are the, and NPTEL notes are also really good, in their theory and their videos are also really good. Okay. Fuse element is generally made of this, I will have to see, because see, just like MCBs and some, depending upon the industrial application, there are different type of fuse elements also. Okay, so like some will have fast acting fuses, some will have slow acting fuses. So usually when you get into the industry, you will understand this. See, even in MCBs, you are having class B, class C, class D, depending upon your application. So say in lighting application, sometimes they take class B or class C, some other application they take class D. So these are a little bit of more in-depth topics. I am not aware of the answer now. I will see. Hariharan, I sleep if I watch NPTEL. See, that is one thing. That is why people like me are there, right? So we put the effort, watch the NPTEL videos and take the best content and give it to you. But then you have to like put some effort. See, yeah, it is a bit slow, but still the content is excellent. The content is really good. The professors, they take a lot of effort and the content is really good. Okay. Anusha has asked, Conan Detective, which reference you follow for electrical machines? Great. The community itself is asking questions to each other. This is what I expect from the people. Help each other. I always tell you, sharing is caring, right? So you have to help each other. So Conan Detective should tell Anusha that which reference he follows for electrical machines. Okay. Manoj, Power Electronics, we are waiting for yours. Anusha has again asked, sir, please answer my question. Anusha, what question? I already answered that question in depth, right? Shweta has asked, please suggest book for ITI electrician. So for these types of courses, you don't need a maybe foreign authors book which are a lot in depth. You will have some books specifically for this, right? For electrician courses. I am not aware of that because I have not taken such courses. So that is the problem. I am not aware of that. Okay. Okay. Manoj, signals is an electronic subject. It's long time since I have seen those subjects also. I only use the applications. For example, in controls we need some signals and system applications. I only use that. Other than taking the theory is a lot of effort. Shivam Saxena, thank you for your hard work. Thank you. Conan Detective, thank you for responding. Happy that you all have participated this properly. Yes, Conan has brought up a point. At Anusha, I used to refer DP Kothari. Yes, Kothari is also another book. See, Kothari, electrical machines by Kothari and Nagrath, right? DP Kothari and Nagrath. I think there are two authors in that. Okay, that book actually you have the explanation divided into a lot of points. A lot of points they have divided the explanation. So that is also a good book. I have not referred Kothari a lot, although I have that book. I have not referred a lot. Okay. Manoj, I have already told you signals. It is better that somebody from electronics background take that subject because that is better. Okay. Yes, Conan, the Kothari is like point they have given the subject. Yeah. And another advice is that, see, it is always better to follow one particular book if you find that good. For example, in Transfomers, at least concepts should be similar. See, the one thing about foreign authors and Indian authors, you see, the phasor diagrams might be a little bit different. In some they take flux to be leading, or in some they take EMF to be leading, right. So what I have done is that I have taken which explanation sounded most clarity to me, I have taken that concept. So once I take for example the one particular component leading the other component, okay, then the entire concept you should follow that only, because ultimately the results will come same. You can see if you in Transfomers you see there is a difference in phasor diagrams from the Indian or a lot of Indian authors and the foreign authors book. In fact I follow the foreign authors book, but ultimately the results are all same, and in fact I have changed a lot of my phasor diagrams to suit my explanation. So that is one thing. So you have to take one concept, use the same concept throughout, okay. So that is the thing. Conan, yes sir. Bablu Yadav, power electronic book, I think Ashfaq Hussain, is it Ashfaq Hussain? There is a book power electronics, not Ashfaq Hussain, I forgot that book name. In fact I have that book in my Kindle, I think I have that book. Other than that there is power electronics. In fact I forgot a lot of authors names. Let me see my library. No, I am not having that book now. Okay, so Ashraf Hussain, something, there is a book like that, Ashraf something like that, for power electronics. Rashid, yes, Conan Detective, you have saved me. Rashid, yes. Ashfaq Hussain is for electrical machines, right. So Rashid is a good book. It's a good author also, in fact it's an excellent author. Other than that, see, for numericals, you see in this foreign authors book you will not find a lot of numericals in the book as such. For that you have to refer another books, for example gate questions, IES questions and all those things, okay. So that is another way of doing all these things. Yes, Conan Detective has told one point very important, better to make your own notes finally after referring anything. That is the important thing. When you are having information from multiple sources, you have to consolidate them in your notebook, and that notebook will be the best notes available, okay. That is better than any book outside. Lot of companies sell these formula books, 200 to 250 rupees you get formula books, right. I would not recommend you buying those books at all, because that book has to be made by you. You should make your own formula book, you should make your own notes. That is the best notes which are, see my notes which I publish in my WordPress page, all I have taken from here and there, and I am making my own notes so that you get the consolidated best notes available. So that is another thing, you have to make your own notes, okay. So yes, so I think if you have any more questions to ask, you can ask me. If you have no more questions, I think we will stop the live session today. The live session, this is the longest live session I have had, 1 hour 12 minutes, my god, lot of questions. So I thank all of you, Conan Detective, Shivam Saxena, Supreme Tuber, Manoj, Bablu, you know one of my colleagues name is also Bablu. Yeah, good friend of mine, Shweta, Anusha, Hariharan, Samiran, Nasir, yes, Parvati, I got the name right, Prabhavati. Thank you all of you for joining today's live session and making it so interactive. The time just literally flew today. So I was very happy with this live session, and remember, this coronavirus is a very serious thing. You should stay safe, stay indoors whenever possible, don't go outside unnecessarily, not at this point of time, at least for the next 2 weeks. Make sure that you clean your hands properly. There are specific guidelines how you have to clean your hands properly, and always maintain hand hygiene, keep social distancing, social distancing, just stay in your house. That's the only thing that you have to do, okay. So I think we will end this stream today, okay, and till I see you in the next video, it's me Varun signing off, and have a great day. Thank you.